Have you ever wondered what gives a lemon that sour punch? Or how soap actually gets your hands clean? Well, the answer is all around us, in the invisible world of acids, bases, and salts. So for the next 5 minutes, we're going to unlock the secrets of these everyday chemicals and turn a whole chapter of chemistry into a quick, simple, and powerful masterclass. And that's exactly what we're going to do. We're going to be your scientific magicians today, cutting right through all the complicated stuff to show you the simple, kind of beautiful science that runs so much of our world. All right, let's jump right in. First things first, we've got to meet the main characters in our story. At the very heart of this topic are two types of substances you've definitely heard of, acids and bases. They're pretty much opposites, but they are absolutely everywhere. Okay, let's break this down. Acids, are sour friends like lemons. They release hydrogen ions, that's H+. A really easy way to remember the test result, just think acids are angry, so they turn litmus paper a warning red. Then you have bases. They're the cool, calm counterpart. They release hydroxide ions, OH-. They're bitter, feel soapy, and they chill that red litmus paper right out, turning it blue. So how do we actually do these color-changing tests? We use these little chemical spies called indicators. This cheat sheet right here, it's a total game changer for your exams. We already know litmus red for acid, blue for base, but look at phenolphthalein. It goes from totally colorless in an acid to a bright, vibrant pink in a base. And get this, even the turmeric from your kitchen spice rack is a secret agent. It stays yellow in acid, but if you've ever spilled curry on your shirt and try to wash it, you know a splash of basic soap turns that stain reddish-brown. See, science is everywhere. Identifying something as an acid or a base is really just step one. The real question, the important question is, how acidic or how basic is it? And for that, we're going to need a scale. And that brings us to one of the most important concepts in all of chemistry, the pH scale. Okay, think of the number 7 as home base. It's totally neutral. Anything below 7 is an acid, and anything above 7 is a base. But here's the part you've got to remember. The further you get from 7, the stronger it is, and it gets stronger fast. Moving from a pH of 2 to 1 isn't just one step stronger. It's 10 times more acidic. So the extremes of this scale are incredibly powerful. Let's look at those extremes. All the way down at one end, with a pH of around 1, you've got the hydrochloric acid that's in your own stomach. It's literally powerful enough to dissolve metal. Right in the dead center, at a perfect 7, you've got pure water. That's our definition of neutral. And then way up at the other end, around a pH of 13, you'll find things like drain cleaner. It's an extremely strong base that can dissolve hair and grease. It's a seriously powerful spectrum. Okay, cool science, but why does any of this actually matter to you? Well, because these exact chemical principles are at work all around us and even inside us every single day. This is where it all gets personal. When you drink a sugary soda, it drops the pH in your mouth, and acid starts to attack your tooth enamel. Your toothpaste, which is basic, is the hero that swoops in to neutralize it. That burning feeling of indigestion, that's just too much stomach acid. A basic antacid is the cure. Even a painful bee sting, which is acidic, feels better when you put a basic baking soda paste on it. Our world is in a constant chemical balancing act. So, what happens when these opposites, acids and bases, finally meet? When they neutralize each other, they create a salt. And we are not just talking about table salt. This reaction is the key to creating some of the most important chemicals used in our world today. Pay attention here, because this is huge for your exams. Now, this might sound super complicated, but it's the process that gets us the ingredients for so many other important compounds. And believe it or not, it all starts with plain old salt water. It's almost like magic, and it's surprisingly simple. Step 1, you start with brine, which is just really, really salty water. Step 2, you run electricity through it. This is called electrolysis, which literally means to split with electricity. And for step 3, that electrical zap separates the brine into 3 incredibly useful things: sodium hydroxide, chlorine, and hydrogen. Okay, now that we have our ingredients, we can start building things. We take that chlorine gas we just made and mix it with something called slaked lime. The result? Bleaching powder. This is the powerful disinfectant that keeps our drinking water safe and our white clothes, well, white. All right, time for some kitchen magic. The reason your cake gets all light and fluffy, that's baking soda. When it gets hot in the oven, it breaks down and releases tiny bubbles of carbon dioxide gas. It's those little gas pockets that make the batter rise and give you that perfect, airy texture. Now, don't get this mixed up with baking soda. Washing soda is a totally different beast. This is a heavy-duty cleaner. It's also fantastic at softening hard water, which basically means it helps your soap and detergents work way, way better. And our final salt is quite literally a lifesaver. Plaster of Paris. See that formula? That hemi just means half, because it only has half a water molecule in its structure. But when you add water back to it, it rapidly hardens into a solid mass. This incredible property is what makes it perfect for setting broken bones in a cast. So there you have it. From the antacid that settles your stomach to the cast that heals your arm, these aren't just abstract ideas in a textbook. They are the invisible forces that are constantly at work in our health, our food, and our homes. This is the chemistry that literally shapes our world. And that's the real magic, isn't it? You now have the knowledge to see the science happening behind the scenes in your everyday life. The next time you brush your teeth or bake a cake or clean a stain, you'll actually understand the little chemical ballet that's taking place. The world is your laboratory now. Go explore it.